if the electronic configuration is 2 to 5, if the electronic configuration is 2 to 5, then it means that in the outermost energy level there are 5 electrons. So if there are 5 electrons, it means nitrogen is in group 5. So that's why we are saying nitrogen is in group 5. Then period is 2. Why period 2? Because nitrogen has 2 energy levels. Nitrogen has 2 energy levels, so it belongs to period 2 of the periodic table. Now again, the valence of nitrogen you need to know also, because when it combines with other elements, the valence of nitrogen will be 8 minus 5, which is 3. You know, for elements which have more than 4 electrons in the outermost shell, the way we get their valences is by getting the maximum number of electrons, which is 8, and we subtract 5. We subtract the number of electrons in the outermost energy level. So the valence of nitrogen is 5. It has atomic number of 7, and it is in period 2 and group 5 of the periodic table. Occurrence of nitrogen. How does nitrogen, where do we find nitrogen? How does it exist? We are saying nitrogen exists as a diatomic molecule because it is a gas. You can never find where we have written nitrogen gas as NO. It is always N2, meaning that it is a gas. All gases exist as diatomic molecules. So it exists freely in air as diatomic molecules and makes up to 78%. This is the composition of nitrogen in air, and it is the most abundant gas. It has the highest percentage. It has the highest percentage. It has the highest percentage. So it occurs also in other compounds. We have compounds which contain nitrogen. For example, nitrates, nitrites. So it occurs in combined states as nitrates. Then it can also occur as nitrates. And most of these are distributed everywhere in soil, such as ammonium phosphate. In ammonium salts, we also have nitrogen, sodium nitrate, potassium nitrate, calcium nitrate. So any compound that contains a nitrite contains nitrogen. Laboratory preparation of nitrogen. How do we prepare nitrogen? I want you to pay attention here. This is very, very important. Now, remember we have laboratory preparation and industrial manufacture. So if we want nitrogen, a sample of nitrogen in the laboratory, this is what we use. But if we want a sample of nitrogen, on the industrial scale or in an industry, then we use fractional distillation, whereby nitrogen and oxygen are made liquids, or are liquefied, and since they have different boiling points, they can be separated by fractional distillation. So let us look at this. Let's look at this. We have a sample of air, and the sample of air contains carbon dioxide, it contains oxygen, and it contains nitrogen and rare gases. But remember, majorly, the sample of air contains carbon dioxide, it contains oxygen and nitrogen, because the percentage of oxygen is 21% and the percentage of nitrogen is 78. So those are the major components of air. So we feed in a sample of air here. This is a sample of air that we are feeding in. Then this is air now going up, and this is water. Now a sample of air also contains water vapor. Remember, water vapor in the atmosphere is also a component of air. Now this air, which contains carbon dioxide, oxygen, and nitrogen, is passed through sodium hydroxide. If we don't use sodium hydroxide, we can use potassium hydroxide. We can also use calcium hydroxide. Those are some of the substances that absorb carbon dioxide. Those are some of the substances that absorb carbon dioxide. So if we don't use sodium hydroxide, we can use potassium hydroxide, we can use calcium hydroxide. We saw when we are looking at carbon dioxide that all those gases react with carbon dioxide. Now, from there, we pass our gas through heated copper. This is a furnace and it contains copper. What is the role of copper? The role of copper is to absorb oxygen or to remove oxygen. So the sample of air which contains majorly carbon dioxide, nitrogen, and oxygen is first passed through sodium hydroxide. And sodium hydroxide absorbs carbon dioxide. Then copper absorbs oxygen. What does that mean? It means if oxygen and carbon dioxide are removed, you'll be remaining with nitrogen, which is collected over water. So let us now explain our work. We are saying air is made to pass through a solution of concentrated sodium hydroxide. And what is the reason? To remove carbon dioxide. To remove what? Carbon dioxide. Carbon dioxide, so this is the equation, and it is very, very important. Remember, we saw this equation when we were looking at carbon dioxide. We ask you what is observed when carbon dioxide is passed through sodium hydroxide solution. And in this case, there is no observable change. But if carbon dioxide is in excess, you remember, it will form a white precipitate. I hope that is understood. The remaining air is then passed over heated copper to remove oxygen. So the remaining air, when carbon dioxide is removed, the remaining air contains oxygen and nitrogen. But remember, our intention is to prepare nitrogen. So we have to remove oxygen by passing it over heated copper. And this is the equation. That is the equation, as you can see. The nitrogen gas can now be collected over water. So you remember the condition for collecting a gas over water, the gas should be insoluble in water. So nitrogen gas is insoluble in water. That's why it is possible to collect it over water. If the nitrogen is required dry, then it must be passed through a drying agent. And the common drying agent, it means we can pass it over fused calcium chloride. We can pass it through a U cube. Remember, when we use calcium chloride, it is always put in a U cube to remove water vapor. Or it can be passed through a U cube containing glass beads. Or glass beads soaked with concentrated sulfuric acid. When we use concentrated sulfuric acid, it is put in a wash bottle. But when we use anhydrous calcium chloride or fused calcium chloride, remember calcium chloride is only a drying agent when it is anhydrous. The word anhydrous means it does not contain water. Fused calcium chloride to dry the gas. So take note of that. So in summary, when you are preparing nitrogen in the laboratory, pass a sample of air through sodium hydroxide. Sodium hydroxide removes carbon dioxide. Then the remaining air contains oxygen and nitrogen. What do you do there? You pass it over heated copper, which removes oxygen. The equation is here. Then if the gas is required dry, pass it through a wash bottle containing concentrated sulfuric acid or a U-cube containing anhydrous calcium chloride. The nitrogen obtained by this method is denser than ordinary nitrogen since it contains impurities like argon and other inert gases. Preparation of nitrogen by action of heat. So nitrogen can also be prepared by heating ammonium nitrate. Ammonium nitrate, not nitrate. Nitrogen can also be prepared by heating ammonium nitrate. But ammonium nitrate is not readily available, so it is always first prepared by reacting. The ammonium nitrate is formed by a reaction of sodium nitrate and ammonium chloride. So we first prepare ammonium nitrate by reacting sodium nitrate and ammonium chloride. And when we do that, we form sodium chloride and ammonium nitrate. So this ammonium nitrate formed is the one that is heated, and it will give us nitrogen gas. So we are saying on slight warming, the solution of ammonium nitrate decomposes to give nitrogen gas. The nitrogen gas produced is collected over water, as you can see. So what do you learn from here? Ammonium nitrate is not readily available, and it is first prepared by reacting sodium nitrate and ammonium chloride. And the equation is here. Ammonium nitrate, when you heat it, it gives us nitrogen plus water. So other methods are here, but we shall look at them when we start looking at individual gases. When we look at ammonia, we shall look at this equation because ammonia is a reducing agent. Then when we look at ammonia, we shall also look at this under reactions of ammonia. So industrial preparation of nitrogen, I talked about it. I said nitrogen is obtained in the laboratory by fractional distillation. No, this is industry. The first one was laboratory preparation, and now this one is industrial preparation. So industrial preparation of nitrogen is by fractional distillation of liquid air. Liquid air is fractionally distilled, and nitrogen is obtained at a temperature of negative 198 degrees centigrade. Oxygen with higher boiling point is left behind. So I told you about that. Oxygen has a boiling point of negative 183, and nitrogen has a boiling point of negative 196. So the gases are first liquefied, or they are made to be liquids, and then they are separated by boiling, by fractional distillation because they have different boiling points. Remember, that is a common question also. Properties of nitrogen. It is tasteless, it is slightly soluble in water, that's why it is collected over water. It is slightly denser than air, it is neutral gas, does not support burning. Chemical properties of nitrogen. Now, this is where I want you to listen carefully. Nitrogen is relatively unreactive. Nitrogen is generally unreactive or generally inert. What is the reason? Listen to the reason. It is also here. This is because nitrogen, this is because of the presence of a strong triple covalent bonds between nitrogen atoms. The nitrogen gas, nitrogen molecule is joined because there are two nitrogen atoms, and since nitrogen has a valence of 3, those nitrogen atoms are bonded together by 3 covalent bonds. In other words, they form 3 covalent bonds. So these covalent bonds, these 3 covalent bonds, triple bond between the nitrogen atoms, these triple covalent bonds between the nitrogen atoms, they join the nitrogen molecules. They join the nitrogen molecule or the nitrogen atoms strongly. So the bond between two nitrogen atoms is very strong, and it requires a lot of heat energy to break it. So we are saying this is because of the presence of strong triple covalent bonds between the nitrogen atoms in the molecule. Then you can show this triple bond. The triple bonds are hard to break because for nitrogen to react, the bonds holding its atoms must break. If they don't break, then it won't react. So for these bonds for nitrogen to react, these bonds must be broken, and that's when nitrogen will react. So I repeat, why is nitrogen generally unreactive or inert? And I'm saying the answer is because nitrogen atoms are joined by strong covalent triple bond, and that strong covalent triple bond holds the nitrogen atoms in the molecule together strongly, and the triple bond does not easily break. So for nitrogen to react, the triple bond must be broken. This is because the presence of nitrogen of a strong triple covalent bonds between its atoms. These are the covalent bonds. So the triple bonds are hard to break, rendering nitrogen inert. So for nitrogen to react, that the triple bond must be done what? It must be broken. Some reactive metals like magnesium and calcium burn in nitrogen. Now, I want you to remember that there are two metals that burn in both nitrogen and oxygen. And one of them is magnesium, the other one is calcium. So calcium and magnesium, they burn or they react with both oxygen and nitrogen. So we are saying nitrogen is generally inert, but it reacts with burning magnesium or burning calcium. Now, why does nitrogen react with burning magnesium? Now, listen to this also. It is because when magnesium is burning, you know, the reaction of burning magnesium is exothermic. It gives out a lot of heat. So when magnesium burns, it gives out a lot of heat energy. And the heat given out by burning magnesium is the one that breaks the triple bond. So when the heat from burning magnesium breaks the triple bond, then nitrogen atoms are set free and they can now react. So I repeat, nitrogen is generally inert or unreactive because of the presence of a strong triple bond between the nitrogen atoms in the molecule. And for nitrogen to react, this triple bond must be broken. However, it reacts with burning magnesium because burning magnesium produces a lot of heat energy, which breaks the nitrogen, this triple bond between the nitrogen atoms. So when magnesium burns in oxygen, it forms magnesium nitride and it is a green-yellow solid. It is a green-yellow solid. So we may ask you for the observation. Magnesium is gray. When it burns in nitrogen, it forms a green-yellow solid. Now, and calcium also, the equation is here. Why is magnesium nitride like this? Because the valence of magnesium is 2 and the valence of nitrogen is 3. So nitrogen gives magnesium its valence, and magnesium, when they exchange valences, we have the compound like that. Then you have to balance by putting there a 3. Now, another important point is here. These nitrides which are formed here of magnesium nitride and calcium nitride, when they dissolve in water, they form an alkaline gas. There is only one alkaline gas in chemistry of all level, and that alkaline gas is ammonia. So when these nitrides, magnesium nitride and calcium nitride, dissolve in water, they form alkaline solutions. Yes, and a gas with a choking smell is given off. The gas with a choking smell we are talking about is ammonia. So this equation is very, very important in chemistry. Calcium nitride or magnesium nitride, they dissolve in water, form magnesium hydroxide if this was magnesium plus ammonia. And if it is calcium, they will form calcium hydroxide plus ammonia. Take note of that. So we have been looking at chemical properties of nitrogen. So the other chemical property of nitrogen is here, that nitrogen, it reacts directly with hydrogen to form ammonia. We shall still look at this when we look at ammonia. Under suitable conditions, special conditions, we shall look at them when we look at ammonia. And we are saying the process is named as the Haber process. Uses of nitrogen. Nitrogen is used in synthesis of ammonia gas or manufacture of ammonia gas. It is used in the manufacture of fertilizers like ammonium phosphate. Yes, it is used. The atmospheric nitrogen is fixed by thunder or bacteria into nodules of leguminous plants. You remember, nitrogen fixing bacteria, so that stuff. So when nitrogen is fixed in plants, leguminous plants, it acts as a plant nutrient. So just say it is a plant nutrient, we shall understand. Because of its low boiling point, nitrogen is used to cool materials to very low temperature. It is used in manufacture of nitric acid. All these are uses of nitrogen. So I repeat, this part is very important. Every student of chemistry must always remember this part. We said nitrogen is generally unreactive. It has very, very few reactions. Why is it generally unreactive or generally inert? It's because the nitrogen molecule, the atoms in the nitrogen molecule are joined together by a strong triple bond between the nitrogen atoms. So this triple bond holds strongly the nitrogen atoms. Eh? So for nitrogen to react, this triple bond must be broken. Eh? It must be what? Broken, because it is strongly attracting or holding nitrogen molecules, nitrogen atoms together. So the triple bond, the triple covalent bonds are hard to break, rendering nitrogen inert. Eh? But we are saying it reacts with burning magnesium. Okay? Because the heat from burning magnesium breaks the nitrogen triple bond. Okay, can I have questions from you from what I have discussed, from what I have talked about? You are a very active class. Can I have questions from you? Feel free. Yes, Jonah, is it Jonathan? Yes, Jonathan.
Teacher,
Hmm.
teacher,
Yes, please.
what if it reacts with any other? What if it acts with any other, but it doesn't break the triple bond, but like both two bonds are broken, but one bond is left? Does it react?
Now, that one cannot happen. Now, what is the valence of nitrogen? The valence of nitrogen is 3. Eh? So if it is 3, it means the nitrogen atoms must be held together by a triple bond. It must be held together by a triple bond, 3 bonds, because its valence is 3. So you cannot break just one. Eh? You cannot break just one bond. It is very difficult. So you must break the 3 or you don't break all of them. You get me? Because the valence of nitrogen is 3. And that's why it has very few reactions. It reacts with magnesium and calcium. Eh? Not like sodium, not with potassium, not with copper, not with no. So these are the only 2 reactions of nitrogen that you need to put in your head. Nitrogen, then nitrogen and hydrogen forming ammonia gas. Eh? I think you are sorted. But the heat from burning magnesium will break this triple bond. Eh? So the nitrogen atoms are set free. And there they can react. Any other question? Questions?
Peter,
Yes.
so when you're stating one of the physical properties of nitrogen,
Mm.
do you have to put all the properties of tasteless, odorless, all in one point, or you can separate them?
You can separate them. It is tasteless, colorless, odorless. You can separate them because they mean different things. Eh? Taste, you are using your tongue. Some people are just joining. So the lesson is done. You are going to do corrections and then I will send work on Google Classroom. I wish you a good day. God bless you. Greet from your parents.
Amen. Okay.
Thank you.